Hi, we're going to talk about the words used in atomic structure. Now technically I'm going to go over the 4 quantum numbers. Don't let that scare you. For first year chemistry, you really won't use that term quantum number very much. It will plant a seed though and prepare you for further chemistry classes. That having been said, we definitely use specific terms when we're talking about atomic structure, especially inside of electron configuration, and sometimes students will start to interchange words and they don't use them quite correctly. So here you have it. The energy level, so you're thinking the nucleus and then the energy levels that surround the nucleus. So Bohr's model looks like the planetary model, nucleus in the middle, and then the circles outside of that. Those are the energy levels. We will use the symbol N to represent energy level. For example, if I use Bohr's planetary model, here's the nucleus, energy level 1, energy level 2, we do N equals 1, N equals 2. Now, the energy levels are also called shells. So that's your shell 1, shell 2. The lower the energy level, the closer that it is to the nucleus, the greater the Coulombic attraction between the electron, that negative, and the neutron, the positive. The proton, the positive, in the nucleus. It is also called the principal quantum number. Okay, so this is the principal quantum number. If we're looking at electron configuration, it's the large number is going to be that number 1 is the shell. We're in the first shell, the first energy level. Now the word block. So we have the 4 blocks on the periodic table, S, P, D, and F. Now no, there are blocks beyond this. We just don't have any elements that we've made that fill those blocks. The next block is going to be G. A theoretical block. Theoretically, there are infinite amount of blocks. So the block and energy levels. The block is called the subshell. So when we say subshell, I'm just talking about S, P, D, or F. The symbol that we use to represent that is L. Probably won't see that in an AP chemistry class or like a first year high school class, but there's a good chance that you might see it in a college class. It is called the Azimuthal quantum number. So there's your second quantum number. And remember, there are 4 quantum numbers. Every electron has its own unique set of 4 quantum numbers. This represents the shape. So again, S is a sphere, P a set of 3 dumbbells, D a set of 5 dumbbells, and F a set of 7 dumbbells. When you write electron configuration, there's the azimuthal. There's your subshell. And so we'll use the word shell and subshell a lot in AP chemistry, referring to energy level and block. Next, orbital. So sometimes students will interchange, well, in this orbital, but they're really meaning the energy level. They'll say this first orbital, but they really mean energy level. The orbital is easiest to see this if you look at orbital notation. These little lines are the orbitals. You can fit 2 electrons in 1 orbital. So the S subshell has 1 orbital because it has a max of 2 electrons. The P subshell has 3 orbitals because it can fit a maximum of 6 electrons. So these little lines, those are the orbitals. For quantum numbers, it's called the magnetic quantum number, and its symbol is M sub L. M sub L for the quantum number. The last quantum number that we have is the magnetic spin, and its symbol is M sub S. Here is from the Pauli exclusion principle that 1 electron spins up and 1 electron spins down, a plus 1/2 or a minus 1/2. There is a little connection with all of these that I haven't shared in any other video. I thought it would fit well here. Energy level, N. If you square the energy level, it will tell you the number of orbitals in that energy level. So I wanted to do this with you. Let's say that I look at energy level 3, okay? Now let's go ahead and square that. That's going to tell us that we have 9 orbitals. So let's think about everywhere on the periodic table that we have an energy level 3. Okay, we have a 3s, so there's 1 orbital for the s. Travel across, there's 3p. That's 3 orbitals, so 1 plus 3 is going to be 4. And then the only other place that we have 3 is right here, 3d. And the d has 5 orbitals. And so 1 plus 3 plus 5 gives us 9 orbitals. Now, if you want to know the number of electrons that can fit maximum in an energy level, remember, 1 orbital fits 2 electrons. You just multiply that by 2. So times 2 And that tells us there's 18 electrons maximum that can fit in the third energy level. And so you could even say the third shell, shell for energy level. So there you have it, the words for atomic structure, how we use these with electron configuration, and if we're being really, really technical, it's actually the 4 quantum numbers for any of our electrons. So good work, you're doing really well to be learning this. Have a great day.